What are these? Sotong kering? No, these are gloves. So make sure that whenever you are going to play around with chemicals or powder, you need to wear gloves all the time for your own safety. We don't know the nature of the powder. Could be harmful or could be toxic. So even though you know that it is not toxic, it is always a precaution that wear gloves. And make sure after you have wore your glove, and if you are going to use powder, make sure you wear protective mask just like this. Very easy to wear. Just it's the other way around. This is the correct procedure. And also don't forget to wear goggle. This is not Google, this is goggle. Now, because you are going to play around with ethanol or any solvent, don't forget your goggle and facial mask. Now, so what you need to do is, now this is the machine. Before you start everything, make sure you warm up the machine properly. And there are, how many? 4 switches to be switched on. The first one is the switch of the computer. Make sure you switch, okay, if including these 2 switches, not 4 but 6. 1, 2 switch. Then followed by the switch of the computer. Simply open the cabinet and you see the switch over here. Switch it on. Close it back again. And let the computer start up. And go to the machine. There is 1 switch over there. So we have switched on 3 switches just now. This is the 4th one. 4th, 5th, and 6th. Let the computer and the instrument warm up properly. Then we go for your sample. Now, you will be given 1 sample of organic dye. So the dye is in powder form. Unfortunately, our machine, if we are going to use powder, we need a lot of powder. So to minimize the usage of the powder, we just need to take small amount of powder and put it in blank vial, very small amount of powder, and put it in the blank vial and dilute it using ethanol. Now, how much powder do we need? Very small amount. Use, this is chataway, not spatula. This is known as chataway. Very small amount of powder. This is too much. This could be okay. Just this amount of powder is needed. Put it in a blank vial and dilute it using ethanol. Make sure, and it will be just like this. This much is enough, or little bit higher until this level. So this will be the solution of your dye. Now what do we need to do? Alright, let the dye be over here like this, and I need to start up the machine. So the password will not be given to you, and make sure always write your name in the logbook. Logbook are here. So write down your name. What else needed? Date, name, ID, sample name, sample, follow your laboratory manual, start time and finish time, equipment condition. If your the equipment is okay, just write down okay, your signature and remarks if you found out any difficulty using the instrument. The password won't be given. Right? So let us start the machine. Now, what you need to do is to click on the F900 icon over here. This will start the machine. Click it and let the machine start up and warm up. While the machine is warming up, we could fill in the cuvette with our sample. See the cuvette, all the sides are transparent. This is cuvette for PL, very different from cuvette of ultraviolet to visible spectrometer. This is the cuvette for UV-vis. It has one transparent side and one opaque side. Sorry, two transparent sides and two opaque sides. This is for UV-vis. This is for PL. All sides are transparent, so we need to use this cuvette for our sample. Now, okay, don't forget your goggle. Put on your goggle. Make sure, even though you are wearing spectacles, you always need to use goggles. And please do not use contact lens during our laboratory session. Just simply put the tip over here, and make sure when you are using the micropipette, it is always facing like this. It's in vertical form, not in horizontal orientation. Always in vertical orientation. So this is your sample. Okay, this is how you press it. Press until here. Do not press too much. See the difference? Press until here, and release your thumb. It will suck all the liquid. Then press your thumb again, and without releasing your thumb, suck the liquid again. Slowly, do not make it too fast. Press your thumb again. This is not enough, you need to add some more. One more. And that will be fine. Now, how about the waste? Okay, make sure you always put the cap on back again, and this tip need to be thrown away. So where is the dustbin? Always over here. Waste bucket. Now to release the tip, you need to press this button. Just press it, the tip will go away. That's all. Now the machine is standby, already standby mode. So again, don't forget to close the lid. Close the lid. This is the lid. Close it. Again, we need to predict the excitation wavelength. This excitation wavelength we need to predict based on the color of your sample. Now, this will be based on your naked eye. What color is your sample? Is it black? No, it's not that black. Is it red? If it is red, then it will be green. So check the wavelength of green. I won't show you the exact wavelength of green. You need to predict. Just Google it. You have a smartphone, Google the wavelength of green and start keying at this region. 600 nanometer is the excitation wavelength. You need to key in the wavelength. So maybe this is an example, and just put 600. You need to check. If green is 600, yes, let it be 600. And emission wavelength, if your determined wavelength is 600, the emission wavelength will be, it is advisable to put higher than 600, maybe 650. So that will be okay. Just click apply and close. Now, put your sample in the sample compartment chamber. Always put your glass on, your goggle on. This is compartment sample chamber. Take it out. And unfortunately, somebody already used this sample stage. This is not the sample stage for liquid. We need to change the sample stage. Okay, let me change the sample stage for you. Just simply unscrew the stage. This is not the stage. This is not the stage for liquid. This is definitely wrong. Not this orientation. The liquid sample should be slot in vertically. This is already slanted around 45 degrees. So this is not the stage. The stage will be right over here. This is the stage. Just take the stage and slot it over here. Make sure they are facing over there and to the another lens, and you need to tighten up a bit over here. There is a screw over here, and there is a groove down there. You could simply feel the groove and tighten it up. Finished. Simply put this compartment back again and slot your sample over here. Done. Now close the lid, back to the instruments, and click this lambda icon. This is the lambda icon. Click it and click emission scan. So new interface will be shown. So what you need to do is to set the scanning range. So the scanning range will be a little bit longer than the excited state wavelength that you have predicted. The excited state you have predicted is 600, should be a little bit longer, 620, and not more than the predicted emitted wavelength. The predicted emitted wavelength that you have set just now, I show to you again. The predicted emitted wavelength is 650. So the scan range should start from in between these two values. So 620 will be okay. So again, click the lambda button, emission scan. So 620 is okay until less than 2 times lambda. This is starting lambda. Absorb lambda. So 600 times 2 is 1200. We could not use 1200 over here because the maximum limit is 900. So just put 900. Apply, and you could start your measurement. Let it be like that. As you can see that the graph is forming a bell-shaped graph. This is half of bell-shaped graph, so now it's going down. The PL count is going down. This is photoluminescence count times to the power of 4. This is the wavelength. So it's going down right now. Wait until the measurement ended. Done. Now, you could determine the corresponding wavelength of the peak. So this could be the peak. So you just simply could click this button, cursor on this button. Got it? Click cursor button, and one vertical line will be placed over here. Just simply click this button. Simply click your right arrow, then you see that the vertical lines will move until over here. Click it, and voila, it stops over there. So now the corresponding wavelength is stated over here. It's 767 nanometer. So now back to our equation over here. You have predicted. Now you could take off your goggle. You're not playing around with the solvent for the time being. Now this you have set during the parameter setting around 600 nanometer. And from your PL graph, you see that this peak is correspond to 767 nanometer. Now you have achieved your second objective. Now your third objective will be to calculate the energy loss using this equation. This is constant, and you have determined lambda absorbance, which is 600, and determine lambda PL, which is 767, and you could calculate the energy loss just like that easily. Now, how to save the data? Let us turn back to the instrument. How to save the data? To save the data, you need to click File, Save As. Okay, go to it's Q, not Q, sorry. Maybe C, not C. Let us check. Maybe Documents. Yes, in Documents. And click New Folder. Click New Folder. And I will make new folder VSP3452. That is the Advanced Material Laboratory. Click it and make new folder. Create your own folder. For example, my name Saiful Kamaluddin Muzakir. Click it and make name. For example, test 1. This is my own name. Save type as EAI. Save. Again, I show you. Save as this. Do not change anything. Just click save. Okay, you have saved the test 1. And second thing that you need to do is click save. Export to ASCII. ASCII. I don't know the correct pronunciation. I just pronounce it as ASCII. Click it. One pop-up will come out. Just click OK. New pop-up will come out with your folder, and just let it be test 1 and save as text file. Save it. Now the importance of saving or exporting into ASCII is that that file will be used to be opened in Microsoft Excel. Whenever you have open in Microsoft Excel, you need to replot the graph using different software. Extra marks will be given if you are using other software than Microsoft Excel. What are the software that you could use? One is Microcal Origin. You could use Microcal Origin to replot this graph instead of Microsoft Excel. If you are using Microsoft Excel, no extra marks will be given. But if you are using Microcal Origin, which you could download from the internet, or you could ask the software from me, extra marks will be given. That is for lifelong learning marks, meaning that you are not depending on the available or the existing software, but you want to learn new software. That is Microcal Origin. Or you could get even higher marks by editing the image or editing the graph using Adobe Photoshop, for example, or other type of image processing softwares. Now you have saved the data. What you need to do now is close everything. How to close? Just click this button and click this button. Are you sure you want to exit? Yes. And don't forget to take out your sample. Simply open up the lid. Don't worry, we are using only visible light, no harm to your skin. It's not X-ray. Take out your sample. Close the lid and put it in the waste bottle. Put it in the waste bottle, just like that. Close the bottle and wash the cuvette using ethanol for a few times. How to wash the ethanol? Yeah. Before washing the ethanol, make sure you are always using your goggle. Put the goggle on. We have waste bottle or waste beaker. Wash it for a few times. Then finish. Dry out the cuvette. You could just simply put it over here again. And that is all. Cuvette is saved. What else? You need to switch off the machine. How to switch off the machine? Very easy, not complicated. Switch off the computer first. Shut down. Then go to the machine. How many switches that we have switched on? Around 6. 1, 2, 3, 4, 5, 6. Switch any switch. No specific sequence. You could switch this switch first, switch off this switch, followed by this. No specific sequence. And then again switch off this main switch. That is all. So now I have made extended video of demonstration of experiment number 2. Happy hunting of the result. Make sure you prove your hypothesis. You prove all the 3 objectives, then it will be okay. Okay? Happy doing lab works. Thank you.